So now we're ready for another real world scenario, and this is to use storage spaces. Storage spaces is one of the coolest new features in Windows 8, and if you're like me, you have this stack of old hard drives left over from previous upgrades and old computers that you don't use anymore. Well, you can finally get some use out of these old hard drives. One of the challenges with using assorted hard drives like that is you might have a 200 gigabyte hard drive and then a 1 terabyte drive, and you have this assortment of different drives, but you don't want to have to worry about where you keep all your different files. When you have so many different drives, it can be really hard to remember what you use for what. And then if you have a 500 gigabyte drive, well, that fills up pretty fast nowadays, and so you're dealing with running out of disk space way more often than if you just had a single logical volume. Storage spaces allows you to take all these physical drives and make one logical volume. So you can access it like you had one drive that was the cumulative space of all the different drives. One of the side effects of using a bunch of different drives, of course, is that you increase your failure rate by a great deal. If you have 10 drives in there, well, the odds are much higher that any one of those 10 drives would fail than if you just had a single drive. Now, it's not quite 10 times as likely that something is going to fail on any given day, because drives have an expected lifespan. So if your 10 drives have a lifespan of about 5 years, in the first 2 years, most likely none of them are going to fail. But as you get into years 3, 4, 5, 6, the odds of one of those 10 drives failing gets to be much higher than if you just had a single drive. So when you use multiple drives like that, any sort of redundancy gets to be really important. Now, the term redundancy, of course, it means a duplication of data. And it's commonly used with drives to indicate that you have some sort of mirroring or parity or RAID going on. Redundancy protects the loss of any individual drive. So imagine I had an array of 10 drives and one of those drives failed. Redundancy would protect my data so that I could keep accessing my data. Basically, redundancy just stores an extra copy of your data, spreads it across all the different disks in an array. Storage spaces can do this too, which makes it all that much more useful for taking all those old drives and combining them into one useful space. If one of my old drives finally gives up the ghost and dies on me, well, I can keep accessing my data. So let's dig in there and use an assortment of old drives as a single logical volume. Here's my Windows 8 computer, and I will open up the Computer Management Console from the WinX menu and go into disk management here. Now you can see it's asking me to initialize disks. That's because it has 4 brand new disks in the computer, as well as 1 disk from earlier. I won't initialize them now. I just wanted to show you that the drives do exist and are available. You can see they're all different sizes too. So to launch storage spaces, I'll go back to the Start menu and search for storage. You need to look in the settings here and launch the Storage Spaces control panel tool. From here, I'll just click Create a new pool and storage space. A pool is basically a grouping of drives, and then the storage space is the logical volume-like thing on top of it. By default, when you choose to create a storage pool, it will add all unused drives into the storage pool. So here you can see the 5 unused drives attached to this computer, and their varying sizes. We have sizes all the way from 25 gigabytes to 700 gigabytes. This just illustrates that you don't need to have identical drives or even drives of similar capacity. Previous versions of Windows, you were allowed to combine drives into mirroring or striping, but they had to be exactly the same size, or at least the partitions had to be the same size. That could lead to wasted space. Here, we can combine different sizes of drives. So I'll create this pool, and now it's going to ask me for a name. I'll leave that, and then it's going to ask me for a resiliency type. The resiliency is just their term for redundancy. It's actually a better term than redundancy, because redundancy sounds bad, but resiliency sounds good, right? They're the same thing though. So you have some different options here. Simple, no resiliency, uses your existing capacity in the most efficient way possible by not storing any duplicate data. So if the combined total of my 5 drives is 1.5 terabytes, which it is, selecting Simple will allow me to use that entire 1.5 terabytes because it doesn't store duplicate copies of any of the data. If I select a two-way mirror, it stores every bit of data that I write on the drive in two different places. So my maximum capacity is going to be, at best, half of the total capacity. After all, if I store a 10 megabyte file, it's going to store 2 copies of that 10 megabyte file on different physical drives. Therefore, every file is actually consuming twice as much disk space. The next option here, a three-way mirror, really provides you a lot of redundancy. With a two-way mirror, you can lose any one of the drives in your pool and not lose a bit of data. If you choose a three-way mirror, you can actually lose 2 drives out of your pool and continue accessing your data. So if you really can't afford to lose your data, for example, if you don't have a backup, well, you might be better off selecting a three-way mirror. If you have a three-way mirror and you lose one of your drives, it then becomes a two-way mirror. So you need to replace one of those drives if you want to restore your resiliency. The last resiliency option here is for parity. Parity uses the space most efficiently. So when we had a two-way mirror here, you see I had a maximum size of about 776 gigabytes. A three-way mirror gave me 517 gigabytes. Parity gives me a full terabyte. Parity provides the same level of resiliency as the two-way mirror. I can lose one of my drives and keep on trucking because there's an extra copy of every bit of data there. But instead of just storing each bit of data in 2 different places, Parity uses mathematical algorithms to allow your PC to restore missing information if you pull one of the drives out, and it doesn't do it by just keeping an extra copy of it. So you can see out of my 1.5 terabytes, I will have 1 terabyte left, which means 1 terabyte for data, and the remaining 0.5 terabytes is used for that parity recovery information. The interesting thing here is I could lose any one of the 5 drives in my pool and still continue accessing my data because of the parity. So because of the complex mathematical calculations required for parity, it's a little bit slower than the other types of resiliency. Of course, when you're talking about performance, no resiliency is the fastest. Every time you write data, it only has to write it to one place. With a two-way mirror, every time you write a byte of data to the drive, it needs to write that data twice. So suddenly your write speeds are half the speed that they were before. Resiliency doesn't affect your read speeds until you lose a drive, but your write speeds are always slowed down. And with a three-way mirror, it needs to write the data to 3 different places, which can substantially slow down your writes, not good for performance. The parity writes the data to basically 2 different places. First, it writes your original copy of data, but then it needs to perform some parity calculations, and it stores that parity on a different drive. So any form of resiliency results in slower performance, but it's all much better performance if you lose one of your drives, because simple means you won't be able to access your data at all. You'll be glad you had some parity. So I will select parity resiliency to use my disk space in the most efficient way possible, even though I know it's going to require some extra calculations by my processor. Now I'll just create that storage space. Well, I'm excited to be able to get some use out of all those old drives. And you can see right away we didn't have to format the drive. Storage spaces took care of that for us. So I'm just going to click this notification up here, and we'll use Explorer to view our new drive. You can see it appears right there in Explorer. I've got 1 full terabyte free, and I don't know that it's 5 different drives. It just works. I also can't see the resiliency, but if one of those drives fails, well, I'll still be able to access my files. So I'll tell you what, I will create a folder, and then I'll just save a file inside of it so we can look at it later. Here's another scenario, and this one's a little scary. In this one, we lose one of the physical drives from our storage space. This happens. Drives die all the time, and you know what? If you don't have a backup, you better hope you have some resiliency. So what I'm going to do is I'm going to yank one of the drives out of that computer and then start it up again, and we'll see what we can do to recover from it. So here I am in Windows 8. I will open up the computer management console so we can take a look at the disk management tool. And you can see here, even though we took 5 physical drives and combined them into a single storage space, the disk management tool doesn't know this. Storage Spaces hides that architecture. So even the disk management tool thinks it's one physical drive. So if we want to see the individual physical drives, we'll need to use the storage space tool to see that one of them failed. So I'll go back into the Start menu and search for Storage Spaces in Settings. And this is what we see now. Storage Spaces is giving me a warning saying reduced resiliency. Check the physical drive section, and this is the physical drive section right here. You can see that of my 5 drives, 4 are marked OK. One drive, however, has failed. It's showing up as completely disconnected, and this is probably what you'll see when a drive starts to fail. At some point, it's just not going to be available, so it's going to be as if you physically removed it from the computer. That's pretty scary. Let's see if we can still access my very important file. So here's the E drive. And sure enough, so that's great. I was able to save a file into Storage Spaces and then yank a drive out and still access the file. It's all built into Windows. It's really cool. I love Storage Spaces. Now let's see if we can repair this pool. What we can do now is remove this drive from the pool. I need to go up and click Change Settings there because it requires administrative access. So because the drive isn't simply disconnected, I will need to remove it. And what that has done is restored the drive to good condition. One drive was missing, I removed it. Now it thinks everything is okay because the storage pool automatically healed itself. I don't actually have to do anything else. I had a parity selected here, and the 4 remaining drives still provide enough capacity for me to continue using parity. Now, let's say I wanted to replace that existing drive. So what I'll do is I'll shut this computer down now and add another drive in and then add it to the existing pool. All right, so I pulled out the dead drive and I found another old hard drive and stuck it there in its place. So I'll log into Windows and we'll go in and add that new drive to the pool. Once again, I'm just going to search the Start menu for Storage Spaces. Before I can do anything, I have to click the Change Settings button here and go through a user account control prompt. Now I will add the new drive to the storage pool by clicking the Add Drives link here. You can see it detects a new drive. Notice this is a 200 gigabyte drive. The previous failed drive was 25 gigabytes. So I'm just replacing it with a totally different size drive. This makes it way better than the old RAID systems that if you lost a drive, you had to replace it with an identical drive. Sometimes it would be years later and you wouldn't even be able to get the same capacity drive. It was a total pain, but with Storage Spaces and storage pools, you can just throw in basically any size drive that you want. So now with Storage Spaces, you don't have to worry about matching drive capacities or drive speeds. You throw in whatever mess of drives that you have and Windows figures out the best way to use it for you. You can see that's all there is to it now. I stuck that new drive in and it automatically added it to my storage space. And in fact, it actually increased the capacity of the pool. You can see it's already okay and being used a little bit. It's already copied some parity information over to the drive. There's nothing else for me to do. My problem is solved. I lost a drive, but didn't lose any data, and I can expand it either to replace failed drives or to add capacity. Storage Spaces is great. I highly recommend using virtual machines and adding a ton of virtual drives to it and playing with it just like we did here. Once you get a good feel for it, try it out in the real world and just connect all the drives in that you can. This is Tony Northrup for Train Signal, and I hope you found the lesson both educational and enjoyable, and I'll see you next time.